Hello friends! Welcome to our student support program for grade 10 and 11 additional mathematics. In today's session, we're going to look at quadratic functions, more precisely how to sketch graph of quadratic functions. So let's start. So today we are going to learn how to use the maximum or the minimum value of f of x to sketch the graph or to determine the range of a function for a given domain. Let's take an example. Consider the quadratic function f of x, which is mapped onto 2 bracket x minus 1 to the square plus 5. That's a quadratic function. Now, first question, is it a minimum or a maximum? How do we do that? Well, we know that for a function f which maps x onto a bracket x minus b to the square plus c, if a is greater than 0, we have a minimum curve. Now here, a is 2. Now 2 is greater than 0, that is 2 is positive. We have a minimum. Remember, the minimum curve is the U shape. Now, we know that it is a minimum. What do we need to do? Well, we need to find how to calculate the minimum point. How do we do that? Well, remember in the first session, we said that the minimum point is B and C. So in our case, B is 1 and C is 5. Thus, the minimum point is simply 1, 5. Now, we'll call that a tentative sketch. Why do we call that a tentative sketch? Because what do we have as information is simply that a minimum point is at 1, 5. So, that's the graph, and the minimum point will be here, 1, 5. Now, we have the curve. You know that here is the y-axis. Now, what is this coordinate? How do we do to calculate that? Well, this is the intersection with the y-axis. Now, if we have intersection with the axes, if it is with the x-axis, it will imply that y equal to 0. Now, if it is with the y-axis, it will be x equal to 0. You've done that earlier in your grade 9. So, intersection with the axes, y-axis, x equal to 0. So, how do we do that? Well, you just need to replace the value of x with 0. So, that will be f of x equal to 2 bracket 0 minus 1 to the square plus 5. So that will be 2 bracket minus 1 to the square plus 5, which is equal to 7. So now we can do a proper sketch. Right, so that's the minimum. The minimum point is at 1, 5. Intersection with the axis, intersection with the y-axis at the point 0, 7. And what about the range? Well, the range is simply f of x is greater or equal to the minimum value, that is greater or equal to 5. Simple, right? Let's move to another example. Now, if we consider this function, that is f of x equal to negative 2 bracket x minus 1 to the square plus 8. What can we say? Is it a minimum or a maximum? Well, remember, if a is less than 0, we have a maximum curve. In our case, what is the value of a? Well, a is minus 2. Minus 2 is less than 0, that is negative. So we have a maximum curve, that is the N shape. So the maximum point will be given by B, C. Here the value of B is 1 and the value of C is 8. So the maximum point will be 1, 8. Right, tentative sketch. We know that we have a maximum point at 1, 8. So that's the maximum point, which is at 1, 8. This is, remember we talk about that, it is intersection with the y-axis. And here, these 2 points are intersection with the x-axis. So, x-axis implies y equal to 0, y-axis implies x equal to 0. Maximum point, intersection with the y-axis and intersection with the x-axis. So what do we need to do? Well, you need to find these points. How are we going to do it? Simple. First, you will replace x by 0. Why do we do that? Because we know that intersection with the y-axis, x equal to 0. So, if we replace, that will be minus 2, bracket, 0 minus 1 to the square plus 8. Now, 0 minus 1 is minus 1, but minus 1 to the square will be 1. So, that's why we have minus 2 into 1 plus 8. So, minus 2 plus 8 will be equal to 6. So, the intersection will be 0, 6. So, we have maximum and here 0, 6. What do we need to do now? Well, we need to find the intersection with the x-axis. How do we do that? So, now we need to move to the intersection with the x-axis. Remember, intersection with the x-axis, that will mean y equal to 0. So let's replace y by 0. We shall get 0 equal to minus 2 bracket x minus 1 to the square plus 8. So we move the plus 8 on the other side. That will be minus 2 bracket x minus 1 to the square equal to minus 8. So, just be careful here. If you've got negative on both sides, you can divide it. It will be positive. And you move the minus 2 on the other side. Minus 8 divided by minus 2, that will be 4. So here, x minus 1 will be plus or minus square root of 4. So, square root of 4, that's plus or minus 2. X will be minus 2 plus 1, which is minus 1. Or x will be 2 plus 1, which is equal to 3. Therefore, the point of intersection with the x-axis will be minus 1, 0 and 3, 0. We sketch it now. So you've got the graph. That's the maximum point, which is 1, 8. Point of intersection with the y-axis, that's 0, 6. And points of intersection with the x-axis, here it will be 3, 0 and minus 1, 0. Now, what about the range? Well, the range will be f of x is less than or equal to 8. Why is that so? Because the maximum value of the function is 8. Let's take another example. Now consider this quadratic function. We have x squared plus 3x minus 4. Okay, how do we proceed? First step, is it a maximum or a minimum? How are we going to know that? Well, we check the value of a. Now, what is the value of a? Here, a is 1. That is greater than 0. Therefore, we have a minimum curve. Now, the minimum curve is the U shape. You know that now. So, what do we need to do? Well, you need to find the minimum point. How are we going to do that? Let's use the vertex method. That is, the value for the minimum point will be given by minus b over 2a and f of minus b over 2a. So in the function a equal to 1, b equal to 3, and c equal to negative 4. So what do we need to do? Well, you just need to replace that in the formula. So for the x coordinate, x which is minus b over 2a, that's minus 3 over 2 times 1. 2 times 1 is 2. So that's minus 3 over 2. We have the x coordinate. What do we need to do? You need to find the y coordinate. So the y coordinate will be given by f of minus b over 2a. That is f of minus 3 over 2. How do we do that? Well, you just need to replace the x by minus 3 over 2 and you simplify. So the value of y will be minus 6 and 1/4. Therefore, the minimum point will be minus 3 over 2 and minus 6 and 1/4. So we know that the minimum point is minus 3 over 2 minus 6 and 1/4. What do we do? Well, we go for the tentative sketch. So we know that it is a minimum. The minimum point is minus 3 over 2 minus 6 and 1/4. Here, what is this? Well, it is the intersection with the y-axis. And here, intersection with the x-axis. Now, what about the range? Well, the range of the function is given by f of x, which is greater or equal to minus 6 and 1/4. Right. Now, how do we proceed? Well, we need to find these points. Remember, intersection with the axes. X-axis implies y equal to 0 and y-axis implies x equal to 0. So let's proceed. Intersection with the y-axis, you replace x by 0. Where do we replace x by 0? Well, we replace x by 0 in the function. So y equal to x squared plus 3x minus 4. That will be y equal to 0 to the square plus 3 times 0 minus 4, which is minus 4. So the intersection will be 0 minus 4. That's the minimum point. And here we have the intersection. What do we need to do now? Well, we need to find the intersection with the x-axis. So x-axis, you replace y by 0. So that will be x squared plus 3x minus 4 equal to 0. How do we do that? Well, we just need to factorize. That's right. So x plus 4x minus 1 equal to 0. Therefore, x will be equal to minus 4 or x equal to 1. Therefore, the intersection will be at minus 4, 0 or 1, 0. Last step, remember, we need to sketch the graph. So, sketching of the graph, don't forget to put the minimum point, which is minus 3 over 2 and minus 6 and 1/4. Here we have the intersection with the y-axis, which is 0 minus 4, and the 2 intersection with the x-axis. That's 1, 0 and minus 4, 0. Right, now a few exercises for you to practice. You need to sketch the graph and you need to state the minimum, maximum point together with the intersection with the axes and the range of the function. So friends, we have reached the end of our session on quadratic functions, that is, on how to use the minimum or the maximum point to sketch quadratic curves. So what you need to do now is go through the exercises in your textbook, ask your teacher for help if need be. Until we meet again, it's goodbye for now.